Imagine a glass of still water. You drop a little blue ink into it. It spreads, it swirls, and eventually, the whole thing just becomes blue. Now, here is something you have never seen. You never see that blue water suddenly unmix, gathering itself back into a single perfect drop. It feels impossible, right? Like time only moves in one direction. But you'd be wrong. Surprisingly, there is actually no law in physics, absolutely none, that stops that ink from gathering back together. Let's zoom in, way down, past the swirling blue water, right down to the atoms themselves. What are they doing? They are jiggling. They are constantly moving, banging into each other, billions of times a second. Now, imagine we filmed just one of those collisions, just two tiny particles hitting each other and bouncing off like billiard balls. Simple. Now, take that film and run it backward. What do you see? You see two particles coming together, hitting and bouncing apart. Does it look wrong? Does it look like magic? No. It looks exactly like a real collision. If you showed that backward movie to a physicist, they wouldn't be able to tell you which way time was moving. They couldn't tell you if you were playing it forward or reverse, because the laws of physics, gravity, electricity, and how things bounce, they work exactly the same way in reverse. There is no rule down there that says you can only go this way. The atoms don't know about the past or the future. They just hit and bounce. But here is the problem. If every single collision is reversible, if every individual atom could just turn around and go back exactly where it came from, why doesn't the ink do that? Why don't we ever see the blue water separate back into clear water and a drop of ink? If the pieces can go back, why can't the whole thing? To understand why, we have to leave the atoms for a second. They are too small, too fast. Let's look at something you can hold in your hands. A deck of cards. Imagine you open a fresh pack. Ace, 2, 3, 4, all the way to the king. All the suits separated. Perfect order. It is beautiful. It is unique. There is exactly one way for the deck to look like this. Just one. Now, give it a shuffle. Just a little one. The cards get mixed up. The order is gone. Now ask yourself this. If you shuffle it again and again and keep shuffling, will it ever go back to that perfect brand new order? Your gut tells you no. It feels like a rule. Cards only get messier. But is it actually impossible? No. If you shuffle, the cards just move. There is no law of physics that prevents the ace of spades from landing back on top. It could happen, and the mechanics of your hands allow it. So why doesn't it? It's not because the universe hates order. It's simply a matter of numbers. The devastating power of big numbers. Think about it. There is only one arrangement that is perfect order. Just one. But how many arrangements are there that are mixed up? Unimaginable numbers. Billions upon billions of ways for the cards to be in a mess. When you shuffle, you're just blindly picking one of those arrangements. What are the odds you pick the one special arrangement out of the trillions of boring ones? It's practically zero. You aren't seeing a physical force pushing the cards into chaos. You're seeing probability in action. The same thing is happening in your glass of water. There is only one way for the ink to be a nice, round drop, and there are infinite ways for the ink to be scattered all over the place. The atoms are just shuffling. They are jiggling around blindly. They don't mind being in a drop, and they don't mind being scattered. But because there are so many more ways to be scattered, that is what you see. Nature is not fighting against order. Nature is just completely outnumbered by the chaos. Here is the thing that will really mess with your head. Since it is just a game of odds, a game of shuffling, if you wait long enough, it will happen. If you sit and stare at that glass of blue water, and you watch the atoms jiggle and bounce for 1 billion years, and then 1 billion times 1 billion years, eventually, just by sheer accident, all the blue ones will bump into each other and land right back in the corner. They will separate. The water will become clear again. It is not against the law. The police of physics will not come and arrest the water. But here is the catch. You would have to wait a time so long that, compared to it, the entire history of our universe, from the Big Bang until now, is just a flash. A tiny fraction of a second. So, yes, it could happen. It is physically possible. But I wouldn't advise you to sit there and wait for it. Don't hold your breath. This is what we mean when we say time has an arrow. It's not that the film cannot run backward. It's just that the odds are so staggeringly stacked against it that we never, ever see it happen. We mistake a statistical impossibility for a strict law. We think the past is different from the future because we remember the order and we see the mess coming. But to the atoms, it's all just bouncing. So you might be thinking, wait a minute. If atoms are constantly moving, if they have all this energy bouncing around, why can't we just catch them? It sounds like a brilliant idea. We could build a tiny machine, a trap. Let's imagine a very small wheel with saw teeth cut into it, and resting on those teeth is a little latch, a pawl, held down by a spring. It works like a turnstile at a subway station. It allows the wheel to click, click, click in one direction. But if it tries to go backward, the latch jams against the tooth and stops it. We put this tiny machine into a box of gas. The plan is simple. When atoms hit the vanes of the wheel, they push it. The latch ensures it only turns one way. We get free rotation. We get order out of chaos. We get a perpetual motion machine. It seems perfect, but there is a fatal flaw. You see, and for this machine to work, it has to be small. Light enough for a single atom to push it, but because it is small, it is also sensitive. You're forgetting that the machine itself is made of atoms. If the gas is warm, the machine gets warm. And what do things do when they are warm? They jiggle. That little latch, the pawl that is supposed to hold the wheel steady, is not sitting still. It is vibrating. It is bouncing up and down with its own thermal energy. And here is the tragedy of our little machine. Just as an atom comes along to push the wheel forward, the latch, purely by accident, bounces up. The wheel slips. It turns backward. The mathematics works out exactly. The probability of the wheel getting pushed forward is exactly equal to the probability of the latch lifting up and letting it slip backward. You gain nothing, and the wheel just sits there, trembling back and forth. This teaches us the most important rule of the game. You cannot extract order from chaos if everything is the same temperature. To make the wheel turn, to make anything happen, you need a difference. You need one part to be hot and one part to be cold. Without that contrast, without that flow from hot to cold, you are just stuck in the jiggle. You know, there is a funny thing about physics. We have a strict law called the conservation of energy. It says that energy can never be created and it can never be destroyed. It is constant. So, if energy cannot be destroyed, why are we so worried about running out of it? Why do we pay for gas? Why do we talk about an energy crisis? The answer is that we don't buy energy. We buy availability. We buy the opportunity to use it. Think of it like water. Imagine a water mill. The water falls from a high dam, hits the wheel, turns it, and splashes into a pool at the bottom. The water in the pool is still water. It hasn't disappeared. It has the same mass. But you cannot use it to turn the wheel anymore. Why? Because it has lost its height. It has lost its fall. It is now in equilibrium with the ground. Heat works exactly the same way. At the only time we can get work out of nature, to drive a car, to power a light, to move a muscle, is when heat flows from a hot place to a cold place. We need that difference. We need that fall. But entropy says that heat always wants to spread out. It wants to mix until everything is the same temperature. When you burn gasoline, you aren't destroying energy. You're taking concentrated chemical energy and spreading it out as useless heat into the air. The energy is still there, jiggling the air molecules, but it is now like the water at the bottom of the dam. It is spread too thin. It is flat. You can't gather it back up to drive the car again. And this is the destiny of the entire universe. We are slowly burning through all our fuel. The stars are hot, space is cold, and the heat is pouring out, trying to fill the gaps. Eventually, and far in the future, everything will reach the same dull, lukewarm temperature. No more hot, no more cold. Just a vast, uniform soup of atoms where nothing new can ever happen again. Because there is no more energy hill to climb down, it makes you look at yourself differently. Look at your hand. It looks solid. It looks steady. But zoom in again. It is a storm. Your cells are being bombarded. Every fraction of a second, the water molecules inside you, the oxygen, the nutrients, they are banging against your DNA. They are hammering against the delicate machinery that keeps you alive. They are jiggling with that same heat, that same random energy. Most of the time, the machinery holds. It repairs itself. The atoms snap back into place. But remember the odds. Remember the deck of cards. Sometimes, just by sheer bad luck, a molecule hits a gene a little too hard. Snap. A connection breaks. A tiny bit of instruction is lost. A cell forgets exactly how to do its job. It is just an accident, a thermal accident, and a random collision that pushed a piece of you from order into disorder. One accident doesn't matter, but these accidents add up. Day after day, year after year, the damage accumulates. That is what we call aging. It isn't a mystical clock ticking down in the background. It isn't a curse. It is simply the accumulation of billions of tiny, microscopic collisions that didn't go your way. The intricate structure that makes you you is slowly being eroded by the random jiggling of the universe. It feels a bit sad, doesn't it? We are fighting a war against the numbers. We are trying to stay organized in a universe that is constantly trying to shuffle us back into the deck. And because there are so many more ways to be broken than to be whole, eventually, the accidents win. So when you see a glass shatter on the floor, or you feel your joints getting stiff, or you see a flower wilt, you are seeing the same thing. You are seeing the arrow of time, not a flow, but a crumbling, a slow, inevitable drift from the miraculous order of the past into the probable chaos of the future. But this brings us to a very deep, very strange question. If the universe is always shuffling, if the natural tendency of things is to mix and spread out, then why was there any order to begin with? Think about that glass of water again. Imagine you walk into a room and you see a glass sitting on the table. In the bottom half, it is pure, clear water. In the top half, it is deep blue ink. Perfect separation. A distinct line between them. You know, instantly, that this glass has not been sitting there for long. You know that someone, or something, must have just poured it. Because if it had been sitting there for 100 years, it would just be a pale blue mix. To have separation, to have order, requires an initial setup. It requires a start. This is the great secret of our history. If we look at the universe today, when we see stars burning out, we see heat spreading, we see things mixing. We are sliding down the hill of entropy. But for us to be sliding down, that means we must have started at the top. At the very beginning, at the moment of the Big Bang, the universe was not a mess. It was incredibly, impossibly organized. It was a deck of cards arranged in perfect numerical order. It was a glass of water with the ink perfectly separated. The energy was concentrated. The structure was tight. We don't know why it started that way. That is the one thing physics cannot answer yet. Who shuffled the deck into perfect order before handing it to us? We don't know. But we do know that everything that has happened since, the formation of galaxies, the birth of stars, the cooling of the Earth, the evolution of life, and you listening to me right now, is just the result of that initial order falling apart. That is why the past is different from the future. The past is simply the direction up the hill. It is the direction of more order, more separation, more potential. The future is just the direction of the slide. We are riding the wave of that initial separation, and everything we do is just a part of the great mixing. There is a strange prejudice we have about time. We think prediction only works in one direction, toward the future. We say, if I drop this stone, it will fall. That is physics. But if I ask you, who was Napoleon? Or, did dinosaurs exist? You don't call that physics. You call that history. But think about it. What is a historian actually doing? When a geologist digs a hole and finds a specific rock, or a paleontologist finds a bone, they are making a prediction. They are saying, because this bone is here shaped exactly like this, I predict that if we could go back in time, we would see a giant lizard walking right here. They are using the evidence of the present to reconstruct the past. But here's the problem. This only works because the universe isn't fully mixed up yet. Imagine our tank of water again, and if you wait until the ink is completely spread out, until it is just a uniform, pale blue liquid, and then you look at it, you can't tell me where the drop fell. You can't tell me if it was one drop or two. The information is gone. The chaos has erased the history. The only reason we can do history, the only reason we can find dinosaur bones or read books about Napoleon, is because the universe is not yet in equilibrium. We are still close enough to that initial state of order that the scratches remain. The footprints haven't been washed away by the tide of entropy yet. So, in a very real sense, history is just the study of those scratches. And the fact that we can know the past at all is just another gift from that low entropy beginning. If the universe had started as a mess, there would be no documents, no memories, and no footprints. There would be no past to remember. So, look at the world around you one last time. The trees, the birds, the light in this room. It is all flowing. We are alive, we are thinking, we are breathing, only because we are riding a wave of order that is washing away. We borrow our structure from the food we eat. The plants build that structure out of air and water, using sunlight. The sun sends us this precious stream of energy, separating the atoms for us, keeping the chaos at bay for just a little while longer. But the sun is just a temporary storage tank. It got its power from the gas clouds that collapsed billions of years ago. And those clouds? They were set up by the Big Bang itself. So, the question isn't really about the ink in the water. The question is, how did the universe start with such perfection? Why, at the very beginning of time, was the deck of cards perfectly sorted? Why was the water perfectly clear? Science can tell us how it falls apart, but we still don't know who set it up. Why was the universe given to us in such a beautiful, unlikely state of order? That is a different story. I'll leave you something to imagine.